Hello and welcome to R&D Mathematics. Today we are going to talk about factoring trinomials. Factoring trinomials. Now a trinomial is a polynomial with three terms. That means a polynomial of this form. Again, please don't confuse with words because a trinomial like this, the degree is 2, right? The degree is 2. The name tri has to do something with 3. That's because there are 3 terms in general. But anyway, let me give you the technique, steps. Let me, just list it in short words like, first what you need to do, find AC. That means multiply the numbers A and C. Second, you have to write down the factors of AC. Factors of AC, all the pairs of AC. Factors, all the pairs. When you see an example, you will understand. Third step, find among all those pairs, find the factor that adds up to B. And then you have to rewrite B using those pairs and then proceed. Now let's have an example and look at this. Then you will understand this clearly. 5x squared plus 7x minus 6. Now all the factoring techniques that you know up to now won't work, right? There is no greatest common factor and you don't see any factoring formula. A plus b squared over a squared minus b squared, nothing here. So you have to use this technique. Okay, first thing that you need to do, find a times c. So first identify a, b and c. A is 5, b is 7 and c is minus 6, so negative 6. So a times c is 5 into negative 6, negative 30. So that's our first step. Then factors of negative 30. Now, so step number 2 and 3 can be done in a table nicely. So factors of negative 30 and sum of those factors. First, how can you get negative 30? So 1 into negative 30 or negative 1 into 30, right? What is the sum of those things? Sum of those things, here negative 29, here positive 29. That number is not 7. So what you are looking for is a pair. When you add, that number is 7. So if you can, without finding all those factors, if you can look at that, that will work. So, but since this is first example, let me list all those. 2 and 15, one of them has to be negative, so let's make it like this. So in first case, it's negative 13, the sum means the sum of these two numbers, 2 and negative 15. And the negative 2 plus 15, it's 13. It's not that number. Next, 3 and 10. See, 3 and 10, you can make 7, but you need to make positive 7. So these are the two combinations. Here negative 7, here positive 7. So this is the combination we want, right? So what you need to do at this step, 5x squared, you can replace 7x by negative 3x plus 10x, because these two together is actually 7x minus 6. Now what you need to do, at this point what you need to do, 5x squared minus 3x plus 10x minus 6. So you have to isolate, catch first two terms and last two terms. Now 5x squared minus 3x, you can pull x out. So you get 5x minus 3. And from the next, you can pull 2 out. So you get 5x minus 3. See, if you have done correctly at this point, you must get the same expression. Because of that, now see, you have two terms. Now listen carefully. Now you have two terms for term number 1, term number 2. In those two terms, one thing is common, and that is 5x minus 3. So you can pull that out. And the remaining part is then x, see here, and here plus 2. So this is the factors, and that's the result. Now, one may have a certain question at this point. Now let me erase this and address. First, let me explain that question. Now here, once you find this pair, negative 3 and 7, so I write down negative 3x, sorry, negative 3 and 10, negative 3x plus 10 in this step. What if I write, can't I change the order? Plus 10x minus 3x. Because 10x minus 3x, that's 7x. That's 7x right here. So, what if I change the order? Will that work? Let's see. Now, first two terms, 5x plus 10x. And in the second two terms, well, I put a minus sign out, then 3x plus 6. And let's see, here I can pull 5x out, then I get x plus 2. See, x plus 2, and see now result, it's going to work. So, and here I can pull 3 out, x plus 2. See, now we have two terms, term number 1, term number 2. So in that two terms you can pull x plus 2 out, and the remaining part 5x minus 3, and the same result. So it doesn't matter at this point which order you go. I think the idea is clear. Now let's do more examples. And how about this? Five x squared plus 9x minus 2. Okay, first step, a times c. So, ABC, 5, 9 and negative 2. So a times c is negative 10. So factors of negative 2, so that when you add those two numbers, you have to get b. So 10. 1 and 10, can I get 9? Yes, so 1 and 10 will give me 9 with what combination? Minus 1 and plus 10, right? That will give me minus 10 when we multiply those two numbers. And when we add those two numbers, it will give me plus 9, right? So you don't have to do the table in all the examples. If you can identify in one shot the correct factor, that's it. So yx squared minus x plus 10x minus 2. So first 2, I will take x out, so 5x minus 1. Second 2, I will take 2 out, so 5x minus 1. See, now I can take 5x minus 1 out, so x plus 2. I think the idea is clear, right? Now let's see, how about this? Another example, let me use a different color. X squared plus 10x plus 9. Now these examples are really easy. Why? Because a is 1, b is 10 and c is 9. So in that case, ac is just 9. So to make 10, 1 into 9, x squared plus 1x plus 9x plus 9. These two I pull x out, so x plus 1. These two I pull 9 out, so x plus 1. Now x plus 1 is common, so x plus 9. See, I think the procedure is clear. So that's all about factoring trinomials. Now let me conclude. How about this example? I have a nice example. Sometimes we may have to use combinations. Now this example. Well, this example is 3, b is negative 6, and c is 3. So you may, well, a times c is 9. Well, you can do that, right? It's not that hard actually in this example, but there is an easy way. See, always try to see whether there is a greatest common factor. In this case, actually, you can pull 3 out first. Then you get x squared minus 2x plus 1. Right? Now, what you need to do, just factor this guy and that guy by observation. That has a nice factoring formula, x minus 1 squared, and that's it. Or you can use our factoring technique. Here a is 1, b is negative 2, c is 1. So a times c is 1. In order to make 1, you just have 1 and 1. And negative 1 into negative 1 will give you positive 1. And when you add those numbers, you get negative 2. So you can replace it by x squared minus x plus 1. So first two terms I can pull x out, so x minus 1. Second two terms I can pull minus sign out, so my x minus 1. See, then x minus 1 is common. Then x minus, here the number 1 is there even though we don't write, so x minus 1 squared. But it's much easier to remember the factoring formula, right? Let me do one more example. How about this? Well, we were talking about trinomials. Actually, now we have 4 terms, but we can use that knowledge. Now in this case, this is a little tricky one. We don't see any greatest common factors, but grouping. Sometimes when you rearrange, see, for example, if I well, I don't even have to rearrange, so x squared minus x, and if I group them as it appears, now nice thing happen. I can pull x out, x minus 1, and here I can pull 2 out, x squared minus 1. Now, sorry, here x squared minus 1. Now x squared minus 1 is common, so I can take that out and x plus 2. Are we done? Not yet, because this has still more factors. X minus 1 into x plus 1. Now we are done. Okay. Let me see. Yeah, it can be combination of all of these cases. I think that's enough number of examples for factoring trinomials. Thank you.